Dr. Radioactive from France. Actually, the last original speaker was not able to make it, so he's presenting on behalf of him. So the title is Functional Nanomaterials based on carbon dots for the extraction of radioactive metals from wastewater.
Thank you. Good morning. First of all, I would like to acknowledge the organizing committee to give us the opportunity to present this here. In fact, we are come from University of Paris, and in this work, we try to present another application of nanomaterials that we developed in the lab. Okay, as you know, for example, why it is very important to have some application some way to treat the problem of radioactivity. As you know, for example, as we all of people know, but there are some problems due to some accident in Fukushima and so on, and also there are some important questions concerning the remediation. So our idea is that how to develop some system that are able to treat this radioactive pollution. In fact, it's a major, this question is a major public health problem. As you know, for example, that many wastes that can obtain in the contaminated water, there are many compounds like uranium, cesium, and so on. And the presence of this compound may induce different kind of disease. So previously in the lab, we have developed different kind of approach how to do some, develop some materials and molecules able to chelate, for example, cesium and uranium. We have do some organic molecules, some different kind of ligands, using some nanomaterials, modified materials, using some cyclodextrin, and so on. The system works, but main drawback is that they are very expensive. So the idea is that now the idea is to develop new approach, combining the property of the magnetic property of inorganic materials, such as magnetite, and to combine it with carbon dot. Why we are interested in to develop carbon dot? Because in the lab we use carbon dot as a catalyst, but also carbon dot as a porous material is interesting, for example, for metal extraction. And the idea is to combine these two materials to obtain this kind of functional materials. And the idea is that this kind of functional materials are able to extract uranium dioxide. And to this end, at each stage, we combine different kind of techniques, spectroscopic technique and material techniques in order to understand what is the process. Another point, we are observe also that in our previous work, we have shown that magnetite exhibit some interesting properties such as photothermy. Photothermy is useful, for example, for in nanomedicine application. But here we have shown that by means of some laser radiation, we observe a huge increase of affinity of this system in order to improve interaction. So here the idea is that is twofold. Firstly, to design this kind of functional nanomaterials, and in the second step, to understand what is the physicochemical process that control the property of the system. Okay. Firstly, we elaborate the synthesis of carbon dot by means of ultrasonic synthesis. Here, the idea is that to use very cheap starting materials such as sugar and something like that. And in the other hand, we master the synthesis of iron oxide materials by means of polyol synthesis. And after that, we graft by means of covalent bonding with carbon dot at the interface. And we combine different kind of techniques to characterize these obtained materials. Okay. Here, for example, we have, after the synthesis of the carbon dot, we characterize it. We show, for example, the UVVs and the luminescence of the carbon dot. We are characterized also by means of solid state NMR. As you can see here, for example, this carbon dot has interesting fluorescence property because there are some the fluorescence depend upon of the wavelength of excitation. Here, for example, also we show that the fluorescence property of the carbon dot depend upon of the pH. So this kind of property induces that carbon dot is also useful for sensor. But one important thing is that, as you can see here, we analyzed the photothermal property of carbon dot. As you can see here, for example, by means of some invisible and near-infrared radiation, as you can see here, we observe an increase of the temperature. This increase of temperature can be useful, for example, to improve some kinetics and some interaction. Also, carbon dot exhibit, due to the fluorescence property of a carbon dot, it is useful to use some nanoscopy. And in this case, we are able also to visualize the property of the carbon dot. And usually, if there are some interaction between carbon dot and some chemical compound, we expect some change of the fluorescence property. Firstly, from we determine some thermodynamical data by using ITC. As you can see here, for example, it is possible to determine, obtain some thermodynamic data. This obtained data are compared with other techniques. We use fluorescence techniques, and by using Stell-Wörner reaction, we obtain exactly the same value. This indicates that, okay, we are able, by combining these techniques, how the ability of a carbon dot to interact with some metals. Also, after that, after the synthesis of iron oxide metals, we do some surface modification, and this kind of surface modification allows us to graft the carbon dot at the interface. And the thing is that in this case, we obtain a stable structure, and we combine different kinds of techniques such as infrared and XPS and so on, and also by means of fluorescence to show the presence of this structure. Now we try to analyze the sorption property of the surface. So we prepare different kinds of sample, and after some steering, and we analyze the influence of radiation. In this case, we try to investigate what is the impact of the photothermal property of carbon dot concerning the sorption property. We analyze to this end, we determine the sorption capacity at equilibrium, and we can see that we observe in the presence of carbon dot and also in the presence of the laser radiation an increase of the sorption capacity. We determine some thermodynamic data by using Langmuir approach, and we can see here, for example, that here we can see clearly that the presence of the carbon dot at the surface induce a huge improvement of this sorption capacity. At this stage, it's interesting, there are some preliminary results, and the most important thing is that we try to compare with our previous work we've done in the lab. So, as you can see here, for example, these results is so interesting because comparing to this compound, specifically this compound, it is very difficult to synthesize it, and we expect that the combination of carbon dot with magnetic is an interesting way for extraction of metal. So, in order to analyze deeply what kind of interaction take place at the interface, we follow by means of different techniques the presence of uranium after the sorption. here, for example, by means of X-space, by infrared, but also by means of some spectroscopic technique. As you can see here, for example, we can see clearly that the presence of uranium at the surface. And this presence of this phase corresponds to this kind of scheme, which indicates that the carbon dots are able to interact with uranium. And now, as the main property of the carbon dot also is that this system are able to exhibit some photothermal property. The thing is that by means of from irradiation, on observe an increase of the temperature. And the previous work showed that when you apply photothermy in some nanomaterials, we observe some increase of the absorption capacity of the materials. And here, for example, in this case, we observe, we observe a huge increase of absorption capacity. These results indicate that this way combining well-designed nanomaterials and photothermy is an interesting way for radiation, for this kind of application. We show again just the preliminary results. We have also investigated the influence of the change of the photophysical property of the carbon dot by using some nanoscopy technique. In fact, carbon dot exhibits some blinking property, and this blinking property can be followed by means of these nanoscopic techniques. And we can see that when there are some interaction between the carbon dot and the uranium and so on, there are some change of the photophysical property. This is another way to visualize the interaction and also the property during the extraction. So, oops. Okay, sorry. So to conclude, in fact, we have, I would like to show you that we are able to elaborate some carbon dot with magnetic nanoparticles. The main interest to how the carbon dot is interesting is the fact that it's a low-cost materials. And also, this kind of functionalized materials can be used as a sensor for uranyl detection. And with the preliminary results show that laser irradiation enhanced the absorption of uranyl. And we have shown again that this system exhibits a high selectivity comparing to against other metals such as sodium, calcium, and so on. And this work is in progress, and we try to improve the property of the carbon dot. So just to finish, I would like to acknowledge all the people involved in the project and also the funding that support this project. And thank you very much for your attention.
Time for a few questions.
Thank you very much, talk. Can you control the particle size of nanoparticle?
Yeah, we try to define to control the particle size. In fact, we have previously for the inorganic part, we develop by means of polyol synthesis. It is possible to control the size. And for the carbon dot, we use different kinds of techniques. Firstly, we use ultrasonic synthesis. The thing is that by means of ultrasonic synthesis, it is like solvothermal system, and we can control, we can change the duration of synthesis, but also the power that you use. And in this case, we can tune the size. The second thing is that we can control also by changing the starting materials to synthesize the carbon dot. There are some change again. But this is a point question, and this is one question, how to control exactly, and also how to control the doping level of carbon dot to manage the property. Yeah. In fact, we try to do this carbon dot to two kinds of application. First, for to develop some metal-free catalysts, but in the same time, we try to do some environmental application. And the thing is to do some basic investigation by combining different techniques, materials techniques, characterization, in order to understand exactly what happened at the interface.
Quick question. How in this are carbon dioxide reusable, recyclable?
Yes.
How is the process like?
In fact, I think we use the classical process by using by changing the pH and so on. And the fact that we use this magnetic property of the iron oxide allow us to recycle it very easily.
There's no more questions. Let's thank all the speakers again.